Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. In 4-T-butyl iodide, the bulky T-butyl group locks the ring in a conformation where T-butyl is equatorial. Structure A has the I-127 in the equatorial position at C1, trans to T-butyl if T-butyl is equatorial, and structure B has I-127 in the axial position at C1. Moving on to the next step. SN2 reactions require backside attack by the nucleophile 128I along the axis opposite to the leaving group 127I. For a cyclohexane system, backside attack is most favorable when the leaving group is in the axial position because the nucleophile can approach axially from the opposite phase without steric interference from the equatorial substituents. Moving on to the next step. In structure B, I-127 is axial. The nucleophile 128I can approach from the axial direction on the opposite phase, also axial, which is relatively unhindered. This is the preferred geometry for SN2 on a cyclohexane ring. In structure A, I-127 is equatorial. For SN2 to occur, backside attack must come from an equatorial direction, but this trajectory is severely hindered by the axial hydrogens on adjacent carbons, 1,3 diaxial type interactions in the transition state. Equatorial leaving groups are much less reactive in SN2. And for the final step. Structure A with equatorial iodide is the more stable isomer, equatorial substituent preferred. Structure B with axial iodide is less stable. However, for SN2 reactivity, it is the axial isomer B that reacts faster because the geometry allows unhindered backside attack. Because the reaction is an identity exchange, 127I replaced by 128I, same element, the transition state for both reactions involves identical atoms and symmetrical geometry. The transition states are of the same energy in terms of the nucleophile carbon-leaving group arrangement. The difference in rate arises purely from the accessibility of the backside attack trajectory. A. Incorrect. Greater stability of A does not make it react faster in SN2, in fact it is less reactive. B. Incorrect. A does not react faster. The product stability argument is irrelevant for an identity SN2 reaction. C. Incorrect. For A, equatorial I, approach of 128I is actually hindered, not unhindered, by axial H atoms on neighboring carbons. D. Correct. B. Axial iodide, less stable isomer, reacts faster because the axial leaving group allows unhindered backside attack by 128I, and the transition states for both reactions are of the same energy, identity reaction with same nucleophile and leaving group. Therefore, the correct answer is D. Therefore, the correct answer is option D.